I'm doing a bit of a cooking video, or rather a video while cooking. I told Kenneth Brown once I'd do it, and I'm cooking now anyway, and I've had a video I wanted to make on my mind for a while. But first let's discuss what I'm making. I'm making Sinterklaasdiner because I'm going to visit my father tomorrow for that, and I promised I'd cook. I rather like cooking. I worked as a cook for a while. My parents have a tourism business in Portugal, and I cooked there for several years as a teenager for guests and so on. Learned the trade a bit there. Worked as a restaurant manager for a while, doing all kinds of stuff, bartending, cooking, all sorts of stuff. So I enjoy cooking. I even once started work on a cooking book, which I might still finish. And the general idea is to make a book of about 100 recipes, which is more a historical book than anything else, focused on what was actual European food like before the colonial period. Because a lot of things that we consider to be typical European food, such as for example pizza in Italy, is influenced by import foods from the New World, from Africa. So for example, pizza with tomato, of course, is not a traditional food. The traditional was focaccia, and then for example a lot of Northern European cooking has potatoes as a staple food, but those weren't generally accepted until the mid 18th century, the 1750s or so. So for example bangers and mash, which would be a typical English food, or what I'm making right now on the andijviestompel, those are not typical European foods. They're considered that because, well, it introduced a lot of variety into our diets. We had what the Dutch, for example, ate a lot of pumpernickel, rye bread, roggebrood, which is apparently quite unpopular in the rest of the world. It's something that is only really eaten in Rijnland-Westphalia, the Netherlands, but that, for example, and then a lot of fish, pickled stuff, a lot of the French kitchen is actually quite similar still to a lot of medieval cooking traditions. A lot of meat, a lot of pies, broths. The Belgians have stoofpotjes, for example, which is, for example, rabbit in beer. That's a typical old European dish. Anyway, what I'm making right now is very classical Dutch food, at least by modern standards. Andijviestompel, erwtensoep vooraf, which is pea soup, which is a very heavy soup. A proper pea soup, you've got to be able to stand a spoon in it upright. And I'm making it vegetarian because I'm vegetarian, but I'll add some sausage and bacon from my dad afterwards separately. Then I'm making witlof, which I don't know the name of witlof in English. It's this stuff. Let me package some for you. These, I don't see them very often in foreign countries, sometimes in France, but generally it's quite delicious. I like them boiled. What I'm going to make is an oven sort of grilled with cheese and mustard and a mustard sauce with a bit of honey carrot on top. So that, and then for dessert, what do you call appelmoes? Appelkompot, I guess, sort of. Mashed apples with sugar and cinnamon. That's also quite nice. At any rate, I might finish that book at some point. Just takes a lot of time, you know. If you're going to make a cooking book, half of it, in my opinion, has to be anecdotes and histories. You know, for example, the commonly known anecdote that salt, that salary is derived from salt because Romans received part of their pay in salt. And I could tell something like how salt works. For example, did you know that sodium chloride, which is salt, how it works is it burns off the sort of calcified part of your tongue, so the upper layer, which has sort of, like in your hands you get calluses, well, dead skin also forms on your tongue. And what sodium chloride does, it burns that off, allowing your taste buds to get a better sense of the food, essentially. That's how sodium works. I found it quite interesting. There's all these little interesting things, like for example, why does hot water clean better than cold water? Because it agitates the molecules, you know, these sorts of things. Of course, I wouldn't make it so scientific because most people don't care that much about it, but little anecdotes, for example, how what would Romans eat on campaign, you know? What's the origin behind certain traditions in Holland, like haringhoppen, these sorts of things. So to get to the point of what I actually wanted to talk about, because this whole cooking stuff was kind of a setup to it, I want to talk a little bit about mathematics, because I've been discussing that with a lot of friends, you know, engineers, economists, people in my circles I know. And they're generally of the opinion that our system of mathematics is basically at its foundation wrong. Now, my expertise in mathematics is mainly in probability and statistics. That's what I know of. I'm not really a physicist or anything like that, but I try to, you know, do a bit of amateur reading, amateur research, keep up with stuff, speak with friends who know a lot more about it. And what they're saying is essentially that we have a few wrong assumptions at the basis of our mathematics systems, which are 0 and infinity. And the one thing to consider is that at a certain level, advancement of mathematics and physics becomes basically indistinguishable from philosophy, because mathematics is just a language to express reality. It's a more rational language, it's a constructed language. It's better than, for example, English, which has roots in Germanic languages, Romance languages. It has a grammar system based on Latin. It just doesn't work as a language. But mathematics is a rational, constructed language which better expresses reality. But that's all it does. It reflects reality. So perspectives on how reality works are translated into mathematics and physics, which is why you can have disagreements with it. I tend to follow the work of Roger Penrose. He won the Nobel Prize for Physics this year. And he also has some theories on why infinity and zero don't work, and a deterministic universe and so on. But to basically start, the point is, we have this assumption that between 0 and 1 there is an infinite number of numbers. That's one of the basic assumptions of our mathematical system, that there is an infinity of numbers, that there can always move one decimal point, you know, continue on. And this reflects an idea of reality, because mathematics is of course a reflection of reality, like any language is. But this assumption might be at its basis wrong, because infinity, well, if the universe is infinite and the universe is expanding, what is the universe expanding into exactly? That's one of the questions Roger Penrose poses. And there's a few theories of this. There's the folding universe theory, there's multiverse theory, and Penrose's idea is more or less that there's a sort of cycle where you've got the Big Bang, the matter expands and moves outward and comes back, and then the cycle starts again, sort of. So it's sort of folding back into itself, because it cannot keep expanding forever, because infinity doesn't really exist. Why doesn't infinity really exist? Because the number of particles at the start of the Big Bang is definable. There isn't an infinite number, there is a definable number. An uncountably high number of atoms, molecules, and so on, particles, so on. But there is a definable number, because it doesn't come from nowhere. Penrose's theory is multiverse. It comes from a higher dimension into this dimension. Big Bang started expanding. But the number of particles at the beginning at the Big Bang is definable. Therefore, there's a countable number of particles in the universe. Void isn't quite void. The void of space has protons in it, and you know, rogue particles, electrons, nebulas, dust clouds, these sorts of things. That's not a complete void. There's something there. The rest is often called quantum foam, although you'd have to really consult a physicist to explain to you how that one exactly works. But the basic idea is, because there is a countable number of particles at the beginning of the universe, there is no actual infinity. There is only undefinable, because, see, the way we use infinity in our current system of mathematics, it works. It works. Why? Because on our scale, the universe might as well be infinite, because it's a very big place. Earth is just a tiny, tiny little part of a galaxy. There are thousands and thousands of galaxies. I think our galaxy has something like over 400 million stars, I think, and they all have planets, and then there's comets, nebulas, etc. At any rate, for our intents and purposes, infinity works, because we can basically use it as a synonym to uncountable, but it doesn't actually exist in mathematics, which is why Some advanced mathematics can create paradoxes which don't work in reality. You've got, for example, the Banach-Tarski paradox, which I suggest you look up on YouTube, where they'll have a better explanation. But it's basically that on a sphere, following a set pattern, you can replicate infinity 3 times, which of course shouldn't be able to work. And then from separating that into 2 and 1, you can generate a whole new sphere, and generating matter out of nothing is of course also impossible. So yeah, infinity doesn't really quite exist by our current theories, or by currently established research by, for example, Penrose. What also doesn't exist is the concept of zero. See, I can have 0 onions, right? I have an onion right now, several onions, and once I've eaten those, I've got no onions left. But the concept of the onion is still there. There are onions elsewhere, new onions can grow. If there were actually genuinely no onions, there would not even be the concept of an onion, because there wouldn't be onions. The same goes for molecules. You've got a certain set of base matter, base atoms, 117, I'd have to look at my thing, but 127 I think. Anyway, those are base concepts, if one of them wouldn't exist, one of them wouldn't be there. If you had 0 hydrogen atoms, you wouldn't have hydrogen, basically. Because mathematics is a reflection of reality, which is why you can get logical paradoxes also with 0, not just with infinity. None occur to me right now, but there are a number. And if there were actually absolute 0 in the universe, there wouldn't be a universe, and there wouldn't be a concept of 0 to begin with, because there would be no consciousness to reflect the concept of 0. So those are 2 assumptions in mathematics which are wrong, and they reflect a perspective within physics, quantum physics currently, which is multiverse theory, and within philosophy of the concept of the universe moving towards coherence. So as Penrose's idea is that this universe is sort of cyclical, the amount of matter is definable. Now if the amount of matter is definable, and here it becomes more philosophical, if the amount of matter is definable, then the universe is fundamentally deterministic. Why? Because you can predict the trajectory of every particle from its inception at the Big Bang. Everything is basically pre-planned in a sense, because the momentum from the Big Bang continues on forever according to Newton's laws of sort of physics of momentum, unless encountering other resistance and so on. It's basically predefinable. With a big enough computational model, you could track everything in the universe and predict how everything goes. So in essence, it's deterministic because it's countable and definable. Its route is preset by laws of physics, like thermodynamics, motion, magneticism, so gravity. This is all, with a powerful enough consciousness, computational capacity, you could predict the entire universe. The problem therein, of course, becomes that we can't really compress information. There's this anecdote, was it an Englishman and a German encounter each other, and the Englishman says, "Our most accurate maps to this day now are on a scale 20 to 1. And the German says, "Well, we have a far more accurate map. It's on a scale of 1 to 1. And the Englishman says, "Does it work?" And the German says, "Well, we've never unfolded it." That's sort of the idea, To track everything in the universe, you basically have to be the universe in essence. And that's where sort of I start combining a lot of this physics and quantum physics with Christian theology, because I find this sort of reminiscent of concepts like the Holy Spirit, Calvinist deterministic philosophy, and so on, and the omnipresence of God. Also in quantum physics, something I'd have to read up on, and I'm not going to get into too much now. Consciousness and observation is very important, because essentially it's sort of the principle of if a tree falls in the woods, does anyone hear it if there's no one there to observe? If an electron moves and there's no consciousness to observe it, does the electron even move, and does the electron even exist? And that's Max Planck's principle of uncertainty, Heisenberg's principle of uncertainty, right? Because you can't really exactly measure. Schrödinger. You've got a lot of these examples in quantum physics that it's very hard to actually track the exact place of particles, because as soon as you interfere with it, you're interfering with it to measure it and so on. Anyway, that's something I wanted to just put out there. The fact that actually zero, infinity, and our basic ideas of mathematics are a bit wrong. Possibly, like I said, I'm not an expert, but when I talk to experts, when I read papers on this stuff, that's the impression I get, that that's the trend we're moving towards. Or for practical intents and purposes, we're still using it. For example, Newton's 3 laws of motion also don't quite work. For example, the second law of motion assumes a universe where a zero friction environment is possible, which is of course not true. So the laws of motion Newton's laws of motion aren't quite accurate, but because they're good enough, we use them in our day-to-day engineering and so on, because it's good enough. And so it goes with zero and infinity in our mathematical system. It's when you get to advanced concepts where it starts breaking reality, and that might not be too relevant now, but it might be in future. And also, I think it's philosophically relevant. Again, if a universe is deterministic, that removes a lot of uncertainty from it. It means that there is almost saying that a will is directing it is maybe too much, but there is a certain trackable course. And determinism as a philosophy is quite broad. And if you want, you should read up on that again. Again, I can't go into all of these concepts. This video would be 3 hours long, and I have got dinner to make. But yeah, that's some concepts I want to throw out there and have a discussion about, have people, talk about more. Because again, as I often say, I find the discourse on the public discourse, the discourse especially in our own movement, to be very, very unintellectual and very lowbrow, just discussing the news all the time. That's not what I'm about.